Welcome everyone to the presentation on implementing clean architecture. It's really great to see that so many people are interested in finding out what clean architecture is and how you can implement it. Really brings a smile to my face. The obligatory slide, who am I? I'm a senior Java engineer at ACIT Solutions, a software company in Belgium. I'm not an architect, I'm just a developer, but above all, I'm a software craftsman. What does that mean? I really like working code, but what I really like a lot more is that code is really nice, it's maintainable, it's fun, it's just, if you look at it, it brings a smile to your face. So that means that I also try to concentrate on design and some architecture, on an architectural level, how code should be built and how code should be structured. I also have my own blog, insaneprogramming.be. I try to blog on a regular basis, and it's always in English, so if you want, you can always check it out. So what will we be talking about today? First of all, I'm going to give a quick explanation on what clean architecture actually is. Then I'm going to show you a pure implementation on clean architecture so that it doesn't make any compromises. And then I'm going to show you how you can be pragmatic in implementing clean architecture because of the fact that for some people it will be a bit overwhelming and you want to make some compromises to make it workable in your situation. So what is clean architecture? Are there people here that know what clean architecture is? Raise your hands. Not a lot. Okay, great. Then that's fantastic, so I can do a lot of explanation. So what is it? It's actually a mixed bag of goodies. There are a certain number of architectural styles that have been developed over the years, such as hexagonal architecture with the concept of ports and adapters. And then you also have the onion architecture, the typical layered architecture, of which I'm certain that most of you are working with. And then you also have the concept of screaming architecture. Screaming architecture is not so much a technical, from a technical perspective, but more from a business perspective. It makes sure that your code actually reflects the language that is being spoken by your business and not a technical solution. So you're actually talking the business language and not the solution language. It's actually been around for a while. The core concept like screaming architecture, onion architecture, have actually been here with us for, I think, a lot of decades. But the concept of clean architecture actually got popular thanks to Uncle Bob, who in a 2012 article actually explained how he saw clean architecture within the current ecosystem of software development. And since then, there were a lot of videos on YouTube, amongst which a lot of by Uncle Bob, but also some from Devox Poland or Geekon, and also here in Krakow. So what is clean architecture? This is actually the drawing that Uncle Bob used in his initial article. So it looks a lot like an onion, which it is. And the inner layer, you've got your entities, which is your domain logic. On the layer around that, you've got your use cases, which actually communicate the business capabilities of your system. I'm going to give a lot of examples of what a use case can be. On the outside of that, you've got your controllers, your outside layers, so for example, your REST controllers, but also how you will communicate to the persistence layer, for example, your database or a NoSQL database. And on the actual blue layer is your consumer side, so your devices, your UI, the actual database. If you look at it in a more detailed manner, you have your flow of control, so you come in through a REST layer or a GMS, some way to enter your system. Then you go through your application API to your application layer, which contains the use cases, to your domain, and your domain will be persisted by some other infrastructure layer, such as a database, a caching layer, or even going through an external system through a REST client. So your flow of control will always be from top to bottom, but thanks to the dependency inversion, you're going to have certain blockades in your architecture that make sure that everything stays nicely compartmentalized. This is actually the drawing that Uncle Bob used for showing the component model within a clean architecture. So you've got your basic concept is the interactor and the boundary. The boundary is the use case. But the problem with that drawing is that there is some unclarity on what certain concepts are, such as a boundary or an interactor. So this is actually a bit more of a explanatory drawing of that concept. So you've got your use case, and your use case is your business capability that is implemented by use case implementation, and that is exposed to the outside world through controllers. And the use case implementations use entities and entity gateways to make sure that they get persisted to the outside world. At that moment, I started to panic when I saw all those components. I was like, I'm just trying to build a REST API. Do I really need all those components? I'm just trying to go to the database. But it's actually not that complicated once you start working with it. So what is actually a use case? A use case is just an interface, and an interface that actually communicates the business intent of your application. So in this case, I'm using a property management system as an example, and we have two use cases that we want to build. One is creating a building, and the other one is getting a building. What are you going to do? You're going to build a contract. So for a create building, I want to have my request, and my request, I'm just saying I want to create a building, and in the request, I'm just trying to create a building with a certain name. Same thing with get building. With the get building, I'm just going to get a get building request, which has a building ID, and it gets a building response model, which gets the ID and the name. So this is actually just purely from a business standpoint, what do I want my system to do? Then you can choose whether you want to go to the database layer or you want to go to the outside layer through REST or whatever other system you want to develop, like SOAP or other systems like gRPC, like you saw this morning. So in this case, I'm going to go to the outside layer, and I'm going to expose my use case through REST. In this case, I'm just going to make a simple Spring MVC controller, which injects my use case and exposes it through a post mapping that executes the use case and uses a JSON payload. The JSON payload is just a decoupling of my request model to make sure that I have a perfect decoupling of my application layer, and for example, if I want to use Jackson annotations, that I actually don't have to use those on my request model. Same thing with the get. I'm using the use case for the get building. I'm getting a request inside of it, and I'm using a presenter to transform my response model, which comes out of my API layer, and I'm going to transform it into a JSON structure, which actually looks the same, but for decoupling reasons, it's sometimes nice to have those separate. For example, if you want to use certain formatting of a date, you can put that into the building JSON. Then you've got the okay, and this is the way that you can use a presenter from a Lambda perspective. So you have your response model, and you can add a function that actually allows you to present your model to something else with a function. And that function will then be used inside the getter to build the building JSON instead of just making it directly from the data that is available. So that gives you the opportunity to give you the freedom to choose your exposure. Do you want to do it through REST, JSON RPC, SOAP, gRPC, messaging solutions? It doesn't matter. This is just plain decoupling, and you have freedom of choice there. And the fun part is you can also try this out without even having to build a lot more implementation. The only thing that you have to do is create some mock implementations of your use cases, and then use a simple Spring application boot, a Spring boot runner to start up your application, and you already will have a REST controller that will work with your use cases. Of course, doesn't contain any business logic, but it could be very interesting to use this already. For example, if you're using consumer-driven contracts to make sure that your contract is being validated, or if you want to if you have a UI that already wants a working REST interface, but you don't really have the time to do all the rest already, they can already use that REST interface to build their UI. Then we go to the inside. So we're going to start by building our domain. Our domain is very simple. We just have a building with an ID and a name. And we want some way to manage the persistence of our building. So we're going to build a building entity gateway. An entity gateway just manages the persistence of a certain entity in your system. Has two methods, save and a get. Quite straightforward. So now we can really implement that use case. So now we can implement the use case using the building entity gateway. We inject it, and we use it in the execution method to actually save the building in our system. Of course, you can already try this out again. Just implement a mock entity gateway, and it'll work. So then you already have another piece of the puzzle that you can use to implement your entire use case from front to back. Problem is, I'm just using a basic mocking data. The more sane approach would be then to use an in-memory list, for example, and store that somewhere else. Otherwise, it doesn't really add so much value. But it was just to show you that you can already build a mock interface and don't have to worry about how I'm going to persist my data already. That's something else. That's a concern for a later date. Speaking about later dates, now we're going to implement that gateway. Here I've chosen MongoDB, and I'm using Morphia to build a building document with an ID and just save that document in my database, in my MongoDB. Again, this is another data structure that's being used to decouple my domain model from my persistence model. And once again, you've got complete freedom. Because I'm using an entity gateway, you've got a complete freedom to choose whatever persistence system that you want. Do I want to use MongoDB? Do I want to use JPA, JDBC if you're really old school? Or do you want to use some messaging tools like Kafka? Or you can even layer those entity gateways, for example, if you want to use caching. Or you can even implement your gateway in such a way that it actually accesses an external system. For example, if you have a gateway that needs to access data from an SAP or another system, this is the way to do it. Problem is, this is so much code, and I just wanted to create a post call. This is just so many entities, so many codes. This sometimes makes people a bit apprehensive of implementing clean architecture. Decoupling has a price. You have to build a lot of data structures. You've got your building, which is your domain, which can also contain domain logic if you're using domain-driven design. You've got your request model. You've got your JSON payload for the post call to make sure that you can decouple your JAX annotations, and your building document to make sure that you don't have to use proprietary Morphia annotations on your domain. If you're adding reads, it gets even worse because then you have to implement a response model, which actually decouples your domain model to the outside world. And you have to make a JSON building to make sure that you don't have to use, once again, proprietary annotations like Jackson ones on your response model from your use case. This was actually my reaction when I first saw that. This was way too much code. But once again, it's not really that much code, but it feels a bit wrong to have so much duplication of data structures in your system. So you can be pragmatic. You can make compromises. You can add JPA annotations on your domain. If you know that you want to accept the risk of having JPA annotation on your domain, and you want to accept the fact that you need to add that dependency on your domain layer, that's fine. You can add JSON annotations on your response models and directly expose your response models to the outside world of your controllers. You can expose your use cases through RPC. Not really a good idea, because then you have got some decoupling danger, and then you're actually going to expose a bit of your internal system to the outside world, which can make refactoring sometimes a bit hard, or make your clients a driving role in some changes that you might not want to take. You can return the domain from the use case. Once again, I wouldn't recommend it, because then you are losing decoupling. And then again, sometimes your client can ask certain changes of you in your use case, and you don't want to pull them into your domain because your domain is so nice and it's so clean, and you want to keep it that way. So you're going to have some DDD leakage also. For example, suddenly if you expose your domain through your use case, that means that if you don't use interfaces, they can use certain domain methods in your REST controller, which sometimes you do not want, because there you don't have really transactionality if you haven't chosen for that. So it's a bit of a danger when you do that, but it can be a compromise. Your JSON payload can extend your use case model. So in that case, you can just add certain annotations on certain fields, but you don't have to copy the entire data structure. It just is being used by the extension mechanism. Same thing with the view model. You use the response model, and then it just gets all the fields from the response model, and you can add a certain amount of annotations to make sure that you, for example, some JSON formatting for dates. Problem is, you can also be too pragmatic. You can make bad compromises. For example, you can choose to just forgo all the request models, all the building JSONs, and just use a single data structure throughout your entire application. So you're persisting your domain to the database directly using JPA annotations, and you're adding JSON annotations to expose them directly through your use case. That's mostly accompanied by exposing your gateways directly to the outside world. And the most heard excuse there is, yeah, we're doing just CRUD anyway, so why do I need to put all that code in between? We're just doing create updates, the basic methods that you're going to have on your gateway, so why don't we just expose that to the outside world? But then you're going to have the risk that your client wants to add a field that's actually a calculated field, and then you have to do some really nasty stuff to make sure that your domain still keeps its cleanliness in your system. What I want you to remember is compromises are not a bad thing. You don't have to go pure. You don't have to put all those request models and all those data structures in your system. It can be perfectly acceptable to not go for perfection and just choose a couple of compromises. And that can be the most efficient way for you to write your software. It's nice to strive for that perfection, and the way that we try to implement this, we go as pure as possible until it hurts us. And once it starts hurting us, we started looking at compromises. Know that if you do a compromise, it's actually an acceptable level of technical debt. It's acceptable, but it's debt nonetheless. So the moment that someone starts to tinker with the database and you have to do some changes and you actually are exposing your database model directly through your domain, then you have to start changing your domain because someone changed the database. It's a debt, and someone can collect it, and you have to be very aware of this. A hint that I give is when you start making compromises in clean architecture, keep track of them, document them, and be sure that you are aware of the consequences when you make those compromises. If you have a modular approach, then you also have the concept of dependency inversion. For example, the application API contains your use case interfaces, your request models, and your response models. The REST interface will use those interfaces to actually communicate with your system through your use cases. The application implementation will implement those use cases and will use the domain and the entity gateways of that domain to persist and to get data from your system. Those entity gateways then are implemented by some other infrastructure layer that actually implements those gateways to the outside world. I have a working example, and here you see that you have got your app API and your app impl. And then I've got 3 implementations of my InfraDB layer, one with JDBI, which is actually a sort of a wrapper layer around JDBC that makes it a bit more enjoyable to use it. One with JPA, and one with MongoDB. On the infra-REST layer, I actually made 2 implementations, one with Jersey and one with Spring MVC. I can use any of those combinations without any problems. I can just interchange them whenever I want, and it's very nice to be able to experiment with certain approaches and to have the agility in your architecture to just try something out and see what it gives. So, for example, if you're using Jersey and you want to just want to try out whether Spring MVC would be a better choice for you, you can try that out. And then the deployment module is actually what glues everything together. Here I'm using Spring Boot, but I could just as well have been using Spring Wildfly Swarm or OSGI if you want to. It's a choice that you can make. What is very important is that you try to limit the dependencies in your application API and in your domain. You try to limit the fact that you want to use Spring or you want to use something else. So for example, in my code examples, I'm trying to use add_named and add_transactional, which are JavaX annotations, which are actually compatible with both CDI and with Juice and with Spring. So I can actually choose, I'm actually deferring the choice of my dependency inversion, my dependency injection framework to a later date, whenever I want to. You can also go very fancy with clean architecture. You can start using Kotlin. Because you have very isolated modules, you can just say, okay, I'm going to try to implement one of my InfraDB layers in Kotlin. Why not? The example here is, for example, if you have your use case, the one is the create building implemented with Kotlin and using reactive. So for the people that went to the last session, they know what mono is just a single result, and a flux is a reactive flow of multiple results. So you can go reactive, and you can already use reactive data structures such as mono and flux, even though your entity gateways or your backend is not really compatible with reactive streams. Your use case is just saying, okay, I'm getting a mono or I'm getting a flux, and you can just just fake those out and use you can create a mono from a single object or a flux from a list in your infrastructure layers. You can use event sourcing if you want to. Then you can isolate. You can choose the isolation level of your event sourcing system to where you want to keep it. Do you want to keep it inside your application layer? Do you want to expand it to your domain layer? That's a choice that you can make, and you're actually free to make that choice. Yeah, but what about legacy projects? I'm using legacy. Well, clean architecture can actually be evolutionary. If you have a big system with a lot of services, and those services have a lot of methods, you can just pick out a single method and extract a use case from that method. And then you can choose to go up or down. Do you want to expose that single method use case to the outside world using a REST layer or whatever system you're using, or go down towards the database or any other persistent system you're using. And you can do that completely in a test-driven development style. So you create your use case, you test it, and then you go up or you go down, and you test each and every layer in your system, therefore probably increasing your code coverage in your entire system. So you can pick a single small item in your legacy system and try to apply clean architecture to it, and in the process add more tests and more coverage to your system. So why do we want to use clean architecture? So much code. Well, it makes your code a lot more readable. On the right-hand side, you see a simple screenshot of one of my packages. And this is something that the business even understands. If the business comes at my desk and they want to try to discuss a certain functionality, I can just show them the list of clauses, and they already know what my system can do. They know I can create a building, I can get a building, I can list my buildings, I can evict a tenant from my building, and add a tenant from my building. They don't have to even look into the code to see what my system is actually capable of doing. It's very powerful, because then you can pull your business people closer to yourself, and you're starting to talk the same language. You're not talking, oh yeah, that's that method and that service. Business people don't even know what a service is. So in this case, you're actually adding a common language to your architecture. You have more maintainable code. Each and every layer is nicely isolated, and therefore also easily testable. You can just pick a simple use case and test it, and then you can expand that. So you can use a single layer test, and then it's probably a unit test. You can mock out any of your dependencies. You can use an integration test, and then you can just choose to take together two layers, for example, your REST layer and your use case layer, and mock out the persistence layer, or the other way around. You just mock out the entry point and then go directly to the database. It's a choice, once again, that you can make, or you can even make a complete system test. So you're just going from REST directly to the database, and you've got a complete end-to-end test. Thanks to the dependency inversion system, your modular binaries are also easily enforced. If you use it, like I showed you on one of the previous slides, your REST layer won't even know that there is a domain behind your use cases. For all it cares, it's just a mock interface. They don't know it. They certainly don't know the fact that it's being persisted to a database or a MongoDB. Your REST interface shouldn't even care about the fact that it's being persisted to something or where it's being persisted. It just wants to make certain REST calls available. So what you have to remember is, like I said, you want to use as little frameworks as possible in your inner layers. You just want to have domain logic and business logic. That's it. You don't want to put Spring logic or something else, typical framework logic in there, because at that point, you're getting a lock-in to that certain framework. You're married to that framework. Any of the technological choices are made on the outside. So that means if I want to use REST, SOAP, that's all on the outside. My domain and my application layer don't know how it's being exposed to the outside world, and they don't want to know. They also don't know how it's being persisted. So that choice you can make on the outside layer, and you have easy interchangeability. And that also means easy experimentation. If you want to use for a single use case, you want to try and use MongoDB while the rest of your system is being persisted to a database, perfectly possible. You can just isolate that single use case and just pull out the different entity gateways and implement those in a different way. And your main partition does the runtime wiring. So even though I was using, in my infrastructure layer, Spring MVC, if I was using Jersey, I could even defer that choice to see whether I want to deploy it on a Spring Boot container, in a Java EE application server, if I want to use Drop Wizard, or even if I want to use an OSGI container such as Felix or Karaf. Once again, that's a choice that you can defer to a later choice, and you don't have to worry about that once you start building your system. Your primary concern should be making sure that your business gets the functionality that it wants. How it's being presented to them through a Spring Boot container, Drop Wizard, or an OSGI container, they really couldn't care less. They just want their REST calls. So I'm going to do a little recap. So first of all, clean architecture is nothing new. Most of you are already probably using some aspects of clean architecture, such as an onion layer, an onion layered architecture. And it's really not that hard once you realize that you can make certain compromises. Those compromises really come at a cost, because you lose decoupling on certain levels. But it makes sure that you can actually adapt clean architecture to your own use cases, to your own environment, to your own company. Sometimes the purest way to go forward is not necessarily the most economic way to go forward. You want to deliver code to your clients, of course. But it's really not that hard once you realize that those implementations can be deferred to a later point in time, and that you can just focus on the code that your client wants. So, are there any questions about clean architecture or any of the implementation patterns that you see here? Yes? Normally what you are going to do, so your question is, what are you going to do when you have multiple implementations of your infrastructure layer? How do you combine those, and how do you cope with certain aspects that are duplicate between those two? I said before that you can use layering. For example, if you have caching, your caching layer will be a layered entity gateway. So you have an entity gateway that will add to the caching layer, and then it will inject another entity gateway that actually does the implementation. So in that case, the caching part is actually already extracted from the both of them. Then for the other ones, you can choose to do a partial implementation of your entity gateway. If you know that a certain use case is only using certain methods in your system, in your entity gateway, and it's that use case that you want to use with, for example, a MongoDB while the rest of your application is using a database, you can actually just implement those methods and the rest use a unsupported operation exception because it's not going to be used anyway. And then just use the correct wiring in your main partition to make sure that the wiring is done correctly there. For example, with Spring, you can use profiles or classifiers to make sure that the correct one is being injected. Does that answer your question? Okay. So the question is, if you choose a certain dependency injection framework, do you keep it out of your domain? If possible, yes. Your domain actually shouldn't do a lot of dependency injection, really, because that's just domain logic. I've seen a lot of times that they start using, injecting use cases into your domain. It is possible, but then you're going to add a certain level of complexity to your layer because then you're going to have circular dependencies because your application implementation is implementing your application API, is depending on the domain, and the domain is depending on the application API. So you're going to have a circular dependency in your system, which isn't always that nice to cope with. So my advice would be, try to manage those concerns into your application layer and not do a lot of injection in your domain layer. Try to keep that as contained as possible. Your domain layer should just be contained domain logic and not do any composition of other entities in your system. That should be the concern of your use cases. No more questions? Okay. So thank you, everyone, for listening. I have a working clean architecture example, completely implemented in Java on my GitHub account. I'll post it with a hashtag Devoxx Poland on my Gitter account, on my Twitter account. And I also have certain examples, for example, if you want to use Kotlin, or if you want to use Kotlin with a reactive system, I will, those are just single Kotlin files, and I will also post gists of those on my Twitter account. So thank you, everyone, and have a nice Devoxx.